Hey, actually, I think I want all this. And we'll leave the speakers on. Hey, everybody, good evening. Welcome to week 4 of Advanced Programming with Java here at Portland State University. We've got some interesting stuff tonight. So tonight we begin sort of the advanced part of the Advanced Programming with Java. We're going to be learning about web application development and REST APIs. And it's going to be some good stuff. So we're going to spend most of our time tonight. But we also have the pair programming, the second pair programming exercise for us to do. And I was looking at the Kata, and it's a little bit more interesting than the one last week. So hope people stick around for that. Just as a public service announcement, if you were here last week and participated in the one last week, tonight is optional. Although I encourage you to do it because it'll be good practice, and I think it's kind of a fun problem to solve too. So anyway, but let's start out with Prime Minister's questions. Been a busy week. Lots of good chatter on Slack. I've gotten some good emails. Had some good office hours with some people too. But what can I tell you now? What questions are on your mind? What are some things that maybe you've learned what to share with everybody else? What would you like to know? And feel free to raise your hand in Zoom, here in the classroom, post a question in chat, whatever works for you. So Prime Minister's questions. So for those of you just joining, we are in Prime Minister's questions. Nothing? Project 2, what are your thoughts? What are your questions? Oh, wait a second. Let's see here. Question. Use the late day. Says need to be in by midnight tomorrow. Well, actually, it's 24 hours after the due date. The due date's at 5:30. Technically, it's 5:30 tomorrow. But hey, if you get if you get to me in by midnight, it's okay. We'll figure it out. It's much more important to me that you submit a good quality project that you think you did well on, even if I have to wait a little longer to set. Oh, Canvas said 11:59. Okay, well that's a mistake. That's okay though. I should fix that in Canvas. Oh, really? Canvas. Okay. Okay, a couple questions have come in. Having issues finding a study guide for the midterm. Well, first of all, there isn't a midterm quiz or midterm exam. The midterm is a survey, which is just really it's going to ask you about what you thought of the course so far. So I don't think there's much to study for. But in general, when studying for the quizzes and things like that, the quizzes, and also it'll be true of the final exam. Just looking at the PDFs, the other material and stuff that's here linked on the website, that ought to be enough. But if anybody has a specific question about like, hey, I'd like a little bit more reinforcement there, or you saw a quiz question and you're like, really, did you cover that? Feel free to reach out and I'll show you the slides. Okay. Question from Kyle. We'll be going over mocking in this course. Yes, we will, and we'll see some tonight, I believe. Yes. So we'll be using an API called Mockito to have mock objects in your tests, which you'll see with Java Servlets come in really, really handy because it allows you to test your servlet outside of the servlet container, which means that you can write unit tests you can write true unit tests that run nice and quickly, as opposed to having to rely on integration tests where it starts up your whole web server. And this is exciting stuff tonight, and so I'm getting ahead of myself here, though. Oh, the final exam. You're always thinking so far ahead. We'll talk about it later. But yes, it comes in 2 parts. There's a group and an individual. We'll talk more about that as we get later on in the course. I had a couple questions for you. Project 2, how did it go? What were some of your observations? Was it easier than you thought? More difficult than you thought? About what you thought? File API, yep. Okay, right. So you dove into the details of the file API to just give you more confidence that yes, indeed, your file gets created, or yes, indeed, your file exists. So you put some more logic there as opposed to relying on file writers or do the right thing. Okay. Nice. Okay. Good learning. Okay, well, yeah, it's easy. Yeah, it's like easy to go down the rabbit hole sometimes with these things, and I think that's one of the skills that your entire career, knowing when, yeah, you should really like dig deep and like understand things versus with I'm going to live with the magic. Hey, yeah, cool, excellent. Let's see here. Pedantic misery. Thanks, Jacob. Don't forget to like and subscribe. Let's see here. Easier than I thought, but understanding what I was typing was the hard part. Okay, so a little bit of understanding the APIs and like, okay, you're doing stuff. Okay, good. Well, that's all part of the learning. Even when you can get stuff to work and IntelliJ says everything is green, sometimes you don't understand why exactly. And I think as you work with your code more and you work with the APIs, you'll get that intuitive sense for again, when you should trust the magic and when it's like, no, I really need to be able to understand how to be the magician. Question? Yeah. Yeah, readers and buffer readers. Why are there two objects in order to read from a file? That kind of thing. Excellent question. Yeah. So let's see here. I think text parser is a good example. Well, yeah, text parser is probably a good example. So, if you'll recall from the lecture all about the core APIs, when we talk about the Java I/O API, there are a couple of slides that have like this hierarchy of classes. And for me, this is a good lesson in object-oriented programming, where different classes have different capabilities. And classes that, subclass in our class, have all the behavior of their parent class, and then they add some more, right? Object-oriented programming 101. Well, if you apply that principle to doing I/O, you end up with some common abstractions like reading characters. Actually, sorry, reading characters from someplace, right? And so the API that the reader interface provides is, I've got some source of characters, so you'll read a bunch of characters into a character buffer. Okay, that's sort of fundamentally it. Now, so you have the reader abstraction, and then you have different objects, different classes that represent reading from different sources. So reading from a file, reading from a string in memory, reading from, well, not exactly a socket, but there are all these different kind of readers. And then, so there are different sources. And then there are readers with different properties. So buffered reader provides the read line method. So buffered reader knows how to read an entire line from whatever source. So reader, the most general abstraction, just reads whatever. Doesn't care about lines. Doesn't try to parse anything. Just here are the raw bytes. It reads that. Well, buffered reader then extends that and says, well, okay, I'm going to use the inherited functionality to read some characters, but I'm going to read through a whole line and then return a read line. The line that I read. So, the whole idea, and then what you have, so you have different responsibilities. So a reader is this general, read some bytes from someplace. And then if I want to read some bytes from a file, read some characters. When I read some characters from a file, I use a file reader, right? A subclass of the reader, is reader a class or reader interface? I can never remember. It's class. A subclass of reader that knows how to read from a file. Right, so it knows, its implementation probably uses like the low-level system APIs for reading from files, and so that's all it's good at, right? And that's all, and this is great. We're during office hours, we were talking about the single responsibility theorem, which basically says a class should do one thing and do it well, right? And this is why you don't have, why like when you've got hundreds of lines of code in your class, that's a kind of smelly thing because it's like, it's doing too many things most likely, or what's doing is really complex and there's a better way to represent it. So a file reader, all it knows how to do is read characters from a file. Does it know how to read a line of characters? No, it doesn't. A buffered reader does that. Well, I want to read a line of characters from a file. How do I do that? Well, I take a file reader and I wrap a buffered reader around it. So it uses object composition, having one object defer to another, to provide that functionality. And so then you have all these pieces parts, and then you can put them together in different ways to get the thing that you want. So for instance, if you wanted to read from a socket, then there's a socket object that represents a socket, network connection off to something else, and then that lets you read bytes. And okay, maybe I'm reading characters from that. Okay, so sorry, you have a socket, and then you want to read from the socket, and so then you can get an input stream from the socket, and that gives you the ability to read bytes from the socket. Well, maybe you don't want to read bytes, or what you're reading is characters instead of bytes, and so then you wrap an input stream reader around that object, and if you want to read a line, then you wrap a buffered reader all around that. So you end up with this like object onion, which has all these objects wrapped around or that delegate to other objects to ultimately accomplish the thing, which is like read a line of text from a socket. Right? So it's like these Lego pieces that you can put together. Yeah. Readers and writers closing automatically, yes. Yeah. Well, in general, most file APIs start at the beginning of a stream of data and read all the way through, right? And I mean, this all goes back to like literally like tapes in old computers where sort of the information flows in one direction. Okay, right, and that's sort of conceptually why we have this. So when we, let's say, create a text parser, we send it a file reader, and then here in the parse method, we read all the lines. And as part of reading it, you consume the reader. So it's done, right? And so if you try to read from it again, you'll get it like, no, I'm done. I've already read. And so you get the end of file exception or something like that. Yeah, right, because you had already read all of it. And it's easy to do. I mean, so for instance, here you've got your reader. And so like, hey, let's say you parse your reader here and you still have this reader field. Maybe in another method, you start reading from it again. Oops, and it doesn't work. Yeah. So just remember that these readers are stateful objects. And so, you've got, a pointer to that character stream that you're reading from. That's a very good question. Does the same concept apply with sockets? Yes, conceptually, because a socket is this stream of data. It all depends what you're sending down the socket, though. So, for instance, you open up a socket to a website and you start downloading content. You hit a URL and you get all of that. And at some point, the server is going to finish sending its data, and then you've read it all. Yeah. So, I mean, the socket has an output stream, which is the same output stream that's a file output stream, right? Yeah. Good questions. Sorry, one more other thing on that. I'm using this variant of the try block, which is a try with automatic close, what do they call it? Try with close or something like that. When you have a try, you can have this actually it's statements. You can have these statements in between these parentheses that immediately follow the try. And what this does is that at the end of the try block, I'm recording, right? Oh, good, I am. I always like 5 minutes. And I'm like, oh, yeah, right. Oh, that incredible answer that I'm sure will win me the Turing Award for anyway. Here at the end of the try block, you can have a catch, and because you have this try in parens, everything that's any variable that's declared in here that implements the closable interface, and all buffered readers, and actually all readers implement closable. All of the variables that are declared in here will have their close method automatically invoked when the try block exits. So basically, there's like an implicit finally clause in here. Finally, there's basically an implicit finally clause that invokes br.close. But oh, look, the variable actually isn't available there. But anyway, if it was, so if we declared it, so the alternative is to declare it. Oops, is to declare it up here and then you don't need this. This is the way that it was like originally. So if you see some old Java code, it'll look like this. But IntelliJ's got it in yellow because it says, oh, look, try can use automatic resource management. Well, yes, please. And then, then it does the try with resources. And then gives you that, which is what I had before. But actually, that looks a little better. If I format it, will it stay the same? It will. Okay. Anyway, so that's what that's all about. Any other questions for the Prime Minister? Listen to this nonsense. Nope. Awesome. Okay. So then, so there were a couple of things that came in. I missed missed the chat. So there are a couple of things. What is the difference between extends and implements used in the class first line? Great question. So you declare a class, and classes can inherit things. In Java, every class can have one and only one superclass. If you don't declare that it has a superclass, then it extends a Java lang object. So the extends keyword is what specifies the superclass of the class, so that it extends and inherits all the behavior from that. And you can only extend classes. So interfaces can extend other interfaces. But anyway, implements is used with an interface. Now, an interface, and this is all covered in, I'm sure, the Java language review slides, and then gone into lots of depth in the object-oriented programming slides. An interface is a type in Java that only specifies a contract, only specifies method declarations, but not method implementations. Yeah, quick question? Abstract classes are different. Okay, and I'll get to abstract classes in a moment. So an interface specifies behavior that you have, but not how that behavior is. So it's just method declarations, no method implementations. Like for instance, your phone bill parser is an interface, right? If you go and look at it, I can go show you it. Sorry, let me undo this line of change. 4 steps ahead of myself. Yeah, phone bill parser right here. Looking at code, this is an interface called phone bill parser, and it has a parse method, which is just a declaration. There's no implementation here, right? No curly brackets. Just, yep, phone bill parsers have a parse method, and they return something that extends an abstract phone bill. And that's all it is. So there's no implementation, there's just behavior. And so then here, I have a text parser that class I've declared, and it implements the phone bill parser interface with that returns a phone bill, and therefore this class must provide an implementation of the parse method, right? It overrides the inherited method from phone bill parser. Oops. And because I've bound the type T to phone bill, it returns a phone bill, and so that this class must implement a parse method. So implement is for interface, implements is for interfaces, extends is for classes. And abstract classes are classes that have methods that that don't have implementation. So they're a little bit like interfaces, but I'm sorry, they have some methods that don't have implementations. So they are basically like a class in that they can have methods and fields that have methods and fields that have implementations. And they're also like an interface in that there is some part of their contract, some part of their API, which is not implemented. And then it's up to the subclasses to provide that implementation. As a result, you can't instantiate an abstract class, or you can't say new, abstract. Well, actually, we'll look at another example of that in the phone bill. So the phone bill extends an abstract phone bill. Abstract phone bill is abstract because it has abstract methods like getCustomer. Right? getCustomer does not have an implementation. It's up to your class to provide an implementation of getCustomer. Right? And actually, this is all part of the lesson, right? It's like, right, I wouldn't do this normally in real life. But yeah, right, what these classes are meant to show you, what you're meant to learn about this, is that you've got this abstract superclass, which has a bunch of methods that you need to implement. And then it's got actually toString, which is final, which then can call the abstract methods. And then at runtime, though, you can't instantiate, you can't say new abstract phone bill, because if you went to call the get customer method, what would it do? There's no implementation. It doesn't know. And so the language prevents you from creating one of these objects. Instead, what you need to create is an instance of what's called the concrete class, which in this case is phone bill, which then does provide implementation of those abstract methods from the superclass. Yep. Nice. Good question. Let's see here. Question: when do we need to close these buffers? Well, like I said, in the text parser, because we're using this automatic, what was it called with try with resources? It gets closed automatically, which is nice. They added this language feature because there's a gazillion bugs out there, especially there's a gazillion bugs out there in Java code because people would open a resource but never close it. And so as a result, you have file handles that are open, or you have a big old array in memory that can't be deallocated because there's still a live object that points to it. Well, here, this language syntax makes it much more likely that your resources will get cleaned up. Actually, it guarantees that they'll be cleaned up. Let's see here. Comment here was having the hardest time skipping the first line, but it's so simple. Just read the line once, move on. Yes, learning. LOL, learning out loud? Yeah, never mind. Cool. Sounds like a poster in a middle school classroom, doesn't it? Yeah, okay. Yeah, all these types. Yeah. Actually, let's go to an easier example first. Okay, so so the question is like, wait, there's this type T, and what's this all about? And it's a little confusing. Okay, so we'll start with sort of like the more canonical example, which is collection types. Now, as you probably as you definitely experienced in Project 2, and as you hopefully learned about with the Core API lectures, there are these question or just a realization or a twitch? I mean, okay, yeah. Hope that aha is not turned into an oh no. We'll see. So the Standard Java API has this whole hierarchy of classes of the collections API, and collections gather multiple objects together to represent collections of objects, right? And so then you've seen things like array list. An array list implements the list interface, and the list interface just gives you an index list of objects. Oh, give me the 4th object in that list. Give me the 27th one, right? Very simple API. Array list is an implementation of list, so a concrete class that you can instantiate, an implementation of list that is backed by an array. So you've studied data structures, and there's linked lists, and you can have an array, and you can have red-black trees, not red-black trees. You can have all the trees and things like that for representing sorted lists of data and things like that. So an array list implements the list interface using an array or using arrays. There might be more of them. When these were first introduced, the type you could put the type of data that these collections held was just like any kind of object. Which these are super useful. Everybody loved these when they first came out. I was like, oh, it's because the C++ STL was still pretty immature back in the mid to late 90s, and so like Java was like, oh wow, this is like a collection API that makes sense and is like the same on every platform and blah blah blah. So it was really nice. However, people realized that having everything typed as an object was kind of a pain, because when you have a list of something, it's probably a list of like all the same type, a list of integers, a list of phone calls. But because the API was like any object should be in here, yes, you could put your phone call in there. But then when you went to get it out, you'd have to cast it, because the collection would be like, oh yeah, here you want the 4th element? Sure, here it is. What type is it? I don't know, some object, and you had to like cast it. The code looked ugly. It was much more. There was no type safety to these things. So they added a new feature to the language called generic types, which allows you to express not just a collection of any old objects, but a collection of phone calls. And so then at compile time, it enforces the fact that you can only put phone calls in, and therefore when you go and get something out of that collection, all you're going to get is phone calls. This is really powerful and made the code a lot easier to read, made things a lot safer. Okay, so you have these parameterized types. So collection takes like a collection of something. Tell me what it is. And so when you declare it, it's like, great, this is a collection of phone calls. So then, when you have a parameterized type, it's really, a something of something, a collection of phone calls. I had a problem over the years with the abstract phone call, or the abstract phone bill. So a phone bill is a collection of sorts, right? A phone bill is made up of phone calls. And but part of the assignment is extending somebody else's code. So when I thought about the type of the abstract phone bill, well, initially I just had it be like a collection. Okay. So initially it was just a collection. I didn't have a type T, which meant that your code when we went to get the phone call was just a collection of I don't know, and so then you would iterate over it and have to keep casting the I don't know down to your phone call type. And I said, well, okay, let's learn about generic types, and so then I genericized this by saying, well, it's an abstract phone call that is of type T, where T is some kind of abstract phone call. And let me say it again. Abstract phone bill is contains things of type T, where T is some kind of abstract phone call. Okay. So then when you create your phone bill class, it extends abstract phone bill, and it's an abstract of what? Well, it's an abstract phone bill of your phone calls, right? So this is where it gets a little weird, where like this is your class, this is my class, because your phone call class, subclass my abstract phone call, it is legal to say I am an abstract phone bill of my phone calls. And as a result, the add phone call method always takes your phone call, and get phone calls always returns your phone call. So there's a lot less casting. So now all this came out of the box, and so maybe some of you didn't even notice it, but that's what the T's are all about. But it gives you extra type safety in your programs. Question? Good question. Is this the same as C++ templates? It's not the same. I would say that it's solving similar problems in that you're looking for you have a generic type, or you have a class that is generic in what types it deals with, and you want type consistency, basically saying like a collection. I want to get out the same thing that I put in, right? And that's what this is saying here, where it's like, hey, I want to put in my phone calls, and I want to get out my phone calls, and I don't have to do a lot of casting, and I want to feel confident that the compiler is enforcing it as opposed to relying on runtime checks. Cool. Okay. Excellent. Great questions here to start out with. Oh, R's. There's a T and an R. Remember where we saw the R? Okay. Yeah, I forget which API. Oh, okay. Well, okay. T is just a variable name. It can be anything, right? And just by convention, types are represented by a single capital letter. Now, there are some APIs that have multiple generic types. Think about a map, and we'll see one tonight. A map maps a key to a value. And so then if you look at the declaration, I can go look at this. Actually, I can just go look here. I can say map. I can say util map. Okay. Here, map has a K and a V, which is the type of the key and the type of the value. So as you'll see, we'll have a map of string to strings, and that means that when you put in when you put in objects, it's got to be a string and a string, and when you get the object associated with a string, it will be returned as a string, right? Yep, that's all about. Oops. Sweet, great questions. Oops. Sorry, that was the wrong thing. Here I am. Okay. Okay. Any other questions for Prime Minister's questions? It's good stuff. Okay. Now let's talk about REST. Week 4. Now, so far in the course, the stuff that we've been doing is, let's be honest, this is like CS 100, 200 stuff, right? We've been writing command line programs. Sorry, this is CS 100, 200 stuff in like 1987, right? I mean, right? This is really remember what the goals of the first three assignments were, though, right? It was learning how to parse a command line, getting familiar with Java, using your tools, okay, all that. Not very interesting stuff. If I was teaching like a 100 level course, that's probably what we would do for the entire term. But this is not that. This is advanced programming with Java. And so now we're going to do some stuff that is more complex, stuff that you probably haven't seen before, and stuff that starts making it feel like it's more an advanced course that's appropriate for seniors and graduate students. What we'll be doing in the next phase of our project is writing a client-server program that communicates via REST. And I more so than anything else, I recommend that you watch the Foundations of the Web lecture and maybe the Dependency Injection lecture also, because it talks about mocking. Because this will give you the foundations of developing for the web. We all use the web, and maybe we have a decent idea of things like what the HTTP URL, what URLs are all about, and maybe sort of conceptually everything. But there's details here, and there's things that you may or may not have been exposed to either in your other courses or just in your exploration of computer science. So check those things out; they will help. So what we're going to do in Project 4 is take your phone bill application, and we're going to split it in two. And into two parts, because you're going to have two programs running. So this is one of the things that makes Project 4 considerably more complex. All of a sudden, you've got concurrent programming. You have one process talking to another process. One is your web server, and the other one is a web client. Now, it's still a command line program because it's easy to test, and I'm not going to require that people learn HTML and JavaScript and everything like that. So just to be clear, this is a web application. This is not a web user interface. But what we'll do is we'll take we'll have a server that uses the standard Java Servlet API to respond to a web request. Right, you'll see that we'll be able to hit it inside we'll be able to fetch the URL inside a web browser, right? Because it's a web server, basically what you're running. And then we'll write a client, which is a Java program, which communicates with that web server using the HTTP protocol. So things get pretty complex here. And let me show you some stuff, and then we'll come back to the assignment. So what tonight is going to be is I'm going to be walking you through Project 4 in terms of what Project 4, when you create it, comes out of the box with a toy application, which lets you manage a dictionary in a web application, simple key words and definitions. From that, you'll then evolve a phone bill application. So actually, I think I want the other. Oh, these are both pretty small. Okay. That looks okay. That looks okay. I'm gonna give myself some more screen real estate here. Take my face off the screen, so everybody in the classroom doesn't have to look at my nose. Sorry, people at home. Zoom. Go away. There we go. Okay, so here I am in my check out my GitHub repository. There is a create REST project, and so I will do that. So you are creating a new Maven project for Project 4 because it's very different. It's got all of the Maven. You need a new Maven project because you need all the scaffolding to run a web application. So that's the first thing. So you run that script, and the name of that script for anybody playing at home is create the REST project. Create REST project, and then that creates a new directory called phone bill-web, and so that's where the new project lives. So I'm going to check in this code real quick. Actually, you know what? No, first what I'm going to do is I'm going to run the phone bill web project just to make sure that everything works. Now, this is still Maven, so you run a Maven clean verify, but as we'll see, this does a lot more than what your previous projects did, because there's a lot more to this project. But luckily, Maven has facilities for developing web applications. and it gives you the entire application lifecycle. What the Maven project allows you to do is have things that you're used to, like unit tests, but now it has things you're used to, like unit tests and integration tests. But it also has the ability to build your web application and then deploy it to what's called a web container. But I want to run the project and make sure that everything builds here okay. Good, it has. It compiled the code. It ran the unit tests. It built the web application, the web archive, the WAR file, and then it ran the integration test, and everything passed. So that is good. So now I will. Oops. Let's try this again. Yep, I will add the phone bill web. And let's see here. I've also need to add the POM. Everything is good to go. As you'll see, there's we'll take a look also, but we've got a lot more classes out of the box than we did when we created Project 1. We've got this thing called a phone bill servlet. We have this thing called a web.xml. We have some additional unit tests, and we have some additional integration tests. All good stuff. Then we also have old friends like the pom.xml. So this is cool. Okay, let's get these into GitHub because everything's working, and I want to keep. And if I break things, I want to be able to go back. So added code for project for. Let me do this a little bigger. That font's still ugly too. Okay, and I'll push that up to GitHub. Nice. Okay. And let's just go into IntelliJ, and let's see here. Yeah, this is mine. I am going to refresh. Oh, I don't do that here anymore. Actually, go away. Thank you. Project over here. Do I have my? No, I have my phone bill web. I want to refresh. How do I do that these days? Let's do that here. I want to say reload all from disk. That will pick up my phone bill web. Yep, there it is, and it's indexing it. Does it recognize as a Maven project? It looks like it does. Yep, it's saying frameworks detected, a web framework. That's right, we've got a web application. And so IntelliJ also knows about Java web applications and will give you some features related to the web application that we'll maybe look at later. So you've got a phone bill web. We'll try to close everything else so it's not so distracting. And it has a source directory like we're used to. It has a main like we're used to. It has some classes that are familiar, like, oh, look, a project for, oh, good, a text dumper, a text parser, things like that. It's got a pretty printer. Okay, that's kind of cool. And it's got this thing called a phone bill servlet. And okay, wow, we'll definitely look at that later. And then it's also got tests. Yeah, we've seen tests before. Okay, it's got, text dumper and a phone bill servlet test, and oh, look, there's a whole bunch of APIs. This is really kind of different looking than what we're used to. Again, we'll talk more about that tonight. It's also got integration tests, and I think we're not gonna. We'll see some of that next week. Well, let's just focus on the servlet and the unit tests this week. Okay, so we got code. It's all there. Let's talk about the architecture of our application. Okay. So websites and REST APIs are served up by a web server, right? And what is a web server? Web server is a program that responds to HTTP requests. And we've all worked with URLs, and URL is an encoding of an HTTP request that basically asks for a resource with a given location, right? And so if you look at a URL, HTTP, there's the HTTP, which is the protocol. Actually, let's look at it right here. There you go. There's a protocol, HTTPS, secure HTTP in this case, followed by the name of the machine that it runs on. So there's a machine called web.ccs.pdx.edu. And yeah, I know there might be proxies. Conceptually, it's the machine that it's running on. And then there's some resource that machine can handle. And that is the file part of the URL, or the path part of the URL, which in this case is /whitlock/pdf/rest.pdf. And so then when I type this URL into my browser, the browser will then will look at that URL and will send a request off to web.cecs@pdx.edu and ask for this file. And all of that is part of the HTTP protocol. And then the web server receives that request, handles it, and says, oh, yeah, I know what that file is. I'm going to return that file. And by the way, this is of type PDF. The browser receives that response, says, oh, okay, great, I've got a PDF file. I know how to render one of those. I'll start up, my PDF renderer, and here's all the contents of that PDF file. Great, I'll send that to my PDF renderer, and poof, there it is. So that's how HTTP works. Now, there's some properties of this that are important. Things like the client and the server speak using this protocol. So while the client, the web browser in this case, might identify itself as like, I'm Chrome, I'm Google Chrome, most likely the server really doesn't care. It may do things like, oh, look, it's a mobile browser, or it's a small, this is a small screen. I'll give you slightly different data. But for the purposes of the REST API, it doesn't really care what the client is. So the REST API is going to ask for something like, hey, give me a phone bill. Okay, here's a phone bill. I'll send you this text. Right? It doesn't really care who's asking for it. And that's a very important thing because it allows you to have very different kinds of clients. Most likely in your experiences, you've worked primarily with the web and websites and HTTP in the web browser, right, as you do your things. But along the way, people figured out it's like, well, we can use HTTP for just any kind of data transfer. It doesn't have to be, web browser stuff. So it doesn't have to be HTML files and GIFs and Flash and all that kind of stuff that we did back in the early aughts. We can send anything. Heck, and that's when APIs or REST APIs became popular. People figured out it's like, okay, wow, instead of the same way that I communicate with my database, or that I have two programs that just talk to each other using some protocol, I can just use HTTP. It's a very well-known protocol. There's a gazillion implementations of both sending HTTP and receiving HTTP. Let's use that. That seems smart, and they did. And so then, if you watch the REST lecture, really, that's what it's talking all about, is what this REST thing is all about, and how you can leverage HTTP, the protocol, and its the verbs that it has for getting and putting and updating and all that kind of stuff to provide a remote API between two processes. That's what we're doing here. So. I'll run all this stuff. There you go. I'll run all this stuff in a second. But what you'll see is that we have two Java programs running. One is the web server, and it is implemented using an open source web server called Jetty, which provides a web server that serves up content using the standard Java Servlets API. We'll see what a servlet is. A servlet is basically a Java object that knows how to respond to an HTTP request. And so inside your Jetty, inside your web container, there is something called a web application. And a web application is, in this case, it's like the project, right? It is a series of servlets that provide some functionality. In your case, it's going to be providing a phone bill application to providing a REST API, an HTTP interface over your phone bill application. And inside that web application, there are a couple of things. There are some configuration files. There might be static files like icons and things like that. But really, what there is, the logic that ultimately responds to the HTTP request is in something called phone bill servlet. And phone bill servlet is a Java class, and it has methods like do get and do post, which respond to an HTTP get or an HTTP post. So that's a web server out there, and then you can have various clients hit the URLs that are supported by that web servers. Well, we'll see here that you can use a browser to hit those URLs, and it will return content, and that'll be neat. But what I'm going to test and what you need to implement is a Java program that speaks HTTP to the web server. And so here you're going to have your project 4 main class that uses an object called called a phone bill REST client to make HTTP calls off to the web container. So architecturally, that's how it looks like. Let's take a look at what that actually does in real life. So then, I've got over here on the right, I'm going to run Jetty. And the Maven allows you, or has a plugin for running Jetty. And so you say Maven Jetty run. What that will do is that will rebuild your Java application. We'll rebuild your web application, this phone bill web application, start up a Jetty web server, deploy the phone bill application to it, and then it'll be ready to serve requests. Great. And it said, okay, started Jetty, and it's running on port 8080. So now I'm going to go to my web browser, and I'm going to open up localhost 8080. And it tells me, hey, wait, error not found. Sorry, it gives me a 404, which is the HTTP error code, saying you asked for something that I didn't know how to present you because it's true. I don't have anything at the root URL. Instead, I have something at the phone bill URL. And when I visit that phone bill URL, I get this page right here. This is a page that is served up by your by the Java web application. And if we go and look at IntelliJ, there is a file here in the web app directory called index.html, and this is the HTML that's served up, right? This page contains a couple of HTML forms. This page contains a couple of HTML forms. So inside along with your Java source code, is this HTML file that is that is posted. That is served by the web server. A quick note on this. This HTML form, I'm going to use it tonight to demonstrate some things. It makes for a very nice demo. It is not part of your assignment. So if you are familiar with HTML and HTML forms and you want to leverage it to test your own assignment, great, go for it, have fun. Do you have to? No, you don't. It's just one more thing you need to worry about. So I'll use it tonight to demonstrate some stuff, but it's not a required part of your project. So okay, let's do some stuff. So out of the box, the project comes with a very simple dictionary application that lets you define dictionary entries and then look up words in the dictionary. And you can also list all the entries. So here is the first thing that you do: list all entries. And when I click submit here, and these are HTML forms, so circa 1993. When I click submit, what it does is it goes to a URL which is /phonebill/calls. And it doesn't return anything because there aren't any entries. Okay, sounds good. Similarly, if we go to look up a word, we look up the word Java. Sure, why not? It then goes to a URL, calls, and then $word equals Java. Oops. Oh, and it returned a 404, which is true. There was no word. There's no definition for the word Java, and so it returns a 404. Okay, this is like a well-behaved web application, right? You ask for something that doesn't exist, and it returns a 404. Great, yeah, that's what HTTP is all about. But notice this URL, right? It's the calls file, and then I don't know how familiar you all are with URLs, but then after the file part, you have a question mark, and then you have these parameters that are passed in their key value pairs. Or you've probably seen this before, but maybe you haven't really thought about what it does. Well, you're going to learn what it does. Okay. Let's going back again to the top here. And let's see here. We got about let's take a break in 10 more minutes after I've gone through this a little bit more. So now let's do something interesting. Let's create a dictionary entry, and we'll define the word doe as a deer, a female deer. Okay, we click submit. And that has defined doe as a deer, a female deer. This does an HTTP post. If you go and look at the source code, if you look at the form here, what forms do is takes from a HTML page, it goes and it creates an HTTP request of a given type. So these other ones were just GET, which the same thing as entering a URL in your browser and hitting return. A post, on the other hand, will send a request to the URL and then send some payload with it, with the idea that you are creating data. That's what a post does. It posts data to the server. And what you're doing is you are sending two parameters along with that post: definition, which is in one text box, and then just definition. That's all you're passing in. The definition. No, sorry, you must do the word. Yeah, the word in one in the first text field, and then the definition in the second text field. And so that data gets sent to your to the web server, and it returns defined doe as deer, female deer. Okay. Now, when I go and look at all my dictionary entries, I've got one. Okay, it's doe, a deer, female deer. That's cool. And now let's look up another one. Ray, a drop of golden sun. There, I've got the definition. I look at all my entries. I've got two of them now. And when I go and look up Ray, I get one entry, Ray, a drop of golden sun. Okay. So what am I doing here? I'm using the web browser to interact with my Java Servlet. Let's look at the picture again. Sorry, the picture is back one tab. We're interacting with this web container that's running on port 8080, and my phone bill servlet, which is right now a toy application, is handling those requests to either create an entry in the dictionary or to return the definition of a particular word. Okay. So that is how to access the web application through a web browser. Now, the web application just speaks HTTP. You can use a different kind of client. So we also have a Java client. So let's go to the phone bill web. And so here we also have our old trusty friend, the Java command line program called phone bill. I think it's phone-client.jar. And it's interesting. It takes it has four simple arguments. The first one is the host, excuse me, that you connect to. The other one is the port that you talk to it on, and then you can alternatively have a word if you want to the definition of a word in dictionary, or you can then define a word definition pair by having them both on the command line. So our host is going to be localhost, which is a special name for the machine that we're currently running on, and the port is 8080. And if we run this, don't give it any other arguments, it returns the fact that the dictionary on the server contains two words, doe and ray. So this program is interacting with the web application just like this HTML page does. And the web application doesn't care. All it knows is it receives an HTTP request for, hey, give me all the calls. And so similarly, you can look up words, and then you can also name I call myself. You can add a dictionary entry, and sure enough, if I refresh this page, poof, there it is. How does all this work? Well, this program comes and goes, right? You run that program a lot, and the same thing with this web page, right? We are making requests of the server, and the request is returning, and we're processing it. But the server runs the entire time, right? Our Jetty is still running. So this is different than the programs that you're running so far, and probably most of the programs that you've run as a student, right? It's like it begins, does this thing, it ends. It's all done. Well, no. Here you have the server that runs until you tell it to stop. And it's the thing that is, and it is keeping the state of the dictionary, right? So it is the thing that knows what all of the entries are, and then when you ask for it, you get it. So that's the job of the server, is to provide that. So that's the architecture here. We've got the pieces parts. So we've got two programs talking to each other, and that is very different and much more complex than just one program doing its thing. Cool. So any questions about the architecture or the fundamental things? Yeah. Okay, great question about going from project 3 to project 4. You'll reuse a lot of your code in project 4. Just copy it over into things. So like it's the same phone bill and the same phone call. Your pretty printer needs to be in there. Your text dumper and text parser needs to be in there. But spoiler alert, you're not writing to files anymore. Right? There's no more files. As a matter of fact, an important lesson here is that when the so I'm going to Control C the Jetty server here, and okay, so now if the if I stop the server, no big surprise, I go reload, it's like, oh, localhost ain't there anymore. Okay, that's fine. We'll start the server again. Reload again, and it's empty. All the data is gone because the data lives in memory. And for this project, that's fine. Sure, in the real world, you would write up to a file or to a database or to the cloud or whatever. It doesn't matter, right? But for this program, for this project, all you're doing is storing your phone bill in actually phone bills. You'll be doing multiple of them. Phone bills in memory. Let me check the chat to see if there's more questions. Nope. Okay. Time for a break. Let's take 12. We'll be back at 6:40. And we'll start diving into the code because the code's different. I think you'll find it interesting. Okay. Well, hey, at the beginning of class, we, after Prime Minister's questions, we started looking at Project 4, and Project 4 is a horse of a different color. So we've got two Java programs that are talking to each other over HTTP, and we saw that you've got the web container, which hosts your web application, which is your phone bill application. And right now, instead of storing a phone bill, it stores a dictionary. And we saw that this web application could be accessed through multiple HTTP clients. We started out using a web browser to do things like add a new word to the dictionary. Oops. And we saw also that we could access the application on the command line also. And actually, we can look for things that don't exist. Oh, it throws an exception. Oh, I should handle that a little better, shouldn't I? No, it doesn't give the code. So that's what it does. Now let's start looking on the inside. Let's take a look at how that application works. Now we walked through some of the source code here, and what I want to focus on first is this thing called the phone bill servlet. Now, a servlet is a standard Java API that provides the interface, the contract between the web container, which is something like Jetty, which is an open source project that a bunch of people wrote, and then your code, which is in the web application, the phone bill servlet. And so the whole idea is that your phone bill servlet extends HTTP servlet. And inside your web application, there is a file called web.xml that basically configures the web application to contain that servlet. So you're basically this web.xml tells Jetty, so Jetty will look inside the WAR file that this is bundled in, and it'll read this XML file and say, okay, this web application has a servlet. It's called phone bill servlet. It is implemented by this class called phone bill servlet, and it is mapped to the /calls URL, which means that any web request that is phone bill is the name of the web application, /calls gets routed to that servlet. Okay. So that's what you've done. You've configured a web application to respond to /phone bill /calls. And so then it is that servlet that provides the application logic for the program. So, okay. Let's get rid of some of these tabs. Zoom is just everywhere. I don't want it to be. Let's close all other tabs. Very nice. Okay. Let's take a look at our servlet. So this is a Java class, right? No magic here in terms of the language. And so then you've got a class, an extends another class. We've got some constants up here. We have a field, which is a dictionary that maps strings to strings. So this is a Java object that actually holds the dictionary. And then we've got some methods. Okay, we've got a method called doGet. It overrides something from servlet. Let's see, is that going to tell me what it overrides? Yeah, okay, HTTP servlet has a doGet method. We're going to override that to then implement this servlet's response, our application's response, to an HTTP GET. And so the doGet method takes two objects. One object represents the request that comes in from the client. So when the web browser puts together its HTTP request, it formats it, and this is covered in the lecture. There's a text format that for the HTTP request. It sends that to the web server here, and then what Jetty does is it takes that request, which is all in text, parses it out, creates an object that represents the request, and sends it to the doGet along with an object that represents the response. And the response is the payload that is then returned to the client. So this is what you're doing. This is basically saying, hey, when this servlet receives a GET request, the request will be a request of type GET, or a method GET, of type GET, we'll say that. The request payload, the request information, such as the URL and those C parameters that are passed and everything like that, is all sent in this request object. And then what the method does is it interacts with the request object to get some information. Based on that information, it will interact with the response object to send the response back to the client. Similarly, we've got we've got logic for doPost, and then also there's a doDelete, and then we have some helper methods that we'll see how all this is what this is done, how this is used in a minute. So, okay, that's the source code. Now, I want to walk through the source code with you, and I kind of want to do things in real time. So I'm going to use the Java debugger to walk through this code. So actually, show of hands. Oh, now I want Zoom back. Where is it? Can I get it back here? Good. Let's see here. Show of hands, so raise your hand or otherwise react somehow in Zoom and here in the classroom. Who has used the debugger before? Everybody here in the classroom? We'll say some people in Zoom have. You might be asleep. I don't know. Yeah, there we go. I got some coming up. Yeah, great. People have used debuggers before. Okay. And let's see. I think from what I understand, you like GDB and stuff from like the command line and stuff. Have you ever used a visual debugger? Oh, good. Some people have used a visual debugger too. Yay. Good, good, good. Okay. Well, now we're going to see how to use the visual debugger in IntelliJ. I think more so than your other projects, this project really benefits from debugging. So, but just in case you're not familiar with a debugger, the whole idea is that a debugger is an application that you attach to another application, or maybe you run it in the debugger, depending on how things work. And what it allows you to do is that it attaches to the application in such a way that as the application code executes, the debugger receives information saying, oh, now I'm about to execute this method, or sorry, now I'm about to execute this line of code. And what you can do in the debugger then is stop and pause and watch the code execute at your own rate. And then you can inspect things like the values of variables, or you can evaluate expressions in the context of the running code. It's super powerful, and it's something that you often have to use when things get complicated and hairy, and you really need to understand everything that's going on. So, debuggers have these things called breakpoints. That basically is an indication of like, hey, listen, when this line of code is executed, stop the debugger because now I want to interact with that code while it's running. And the way that you set a breakpoint in Java is that you click over in the gutter and you get the red dot. Now, not every line you can get a red dot on. Here we are in a comment. and you can't set a breakpoint of a comment. It's not running code. And similarly, sometimes like the else statement, I guess you can set a breakpoint there. I'm not too sure what it'll do exactly. So making sure that okay, good. And so then we've set the breakpoint here. And there's a couple of ways to run the debugger. If you are like debugging a unit test, you can do that all through IntelliJ. But here, the Java program that we want to debug isn't launched through IntelliJ. Instead, we're running it over here on the command line using the Maven Jetty run. So it's actually Maven which is running the Java program. So what we need to do is we need to tell Maven, please run in a mode that allows a debugger to connect, right? Because out of the box, you don't necessarily want a debugger to be able to connect, especially in production, right? So then you need to configure it that way. So we're going to stop the Maven program. Yeah. Oh, this one that I'm kind of looking at. Are you going to be able to see that? I don't know if I can or not. No, I cannot. It's got. Can I do this one? No. Sorry, it is the problem that it's at the bottom. You sure? Okay. Oh, because it's obscured by stuff here? Okay, sorry, I will then. Oh, here's what I'll do. I'll just move this up a little bit then. So if we get to the bottom of the screen. So like if I do that, will that be better? Thank you. Okay. Yeah, no problem. Thank you for speaking up. Ah! Can I make it smaller from up here? Yeah. Nice. Okay. So, as we run, when we do the run unit tests, we get these run configurations in IntelliJ. And I don't know if you ever clicked on edit configurations, but there are all sorts of different kind of configurations that you can make. You can add a new one, and oh my gosh, they got like Cucumber test, they got Docker, they got I don't know all this stuff, right? There's only one that I care about, and you can type in and it'll find it. It's called remote JVM debug. So the whole idea is that this run configuration will it tells IntelliJ that you are that IntelliJ is going to connect to a remote JVM. Right, so the JVM that I'm going to run here for Jetty is remote to IntelliJ. It wasn't launched by IntelliJ itself. So you create one of these remote JVM debug run configurations. You give it a name. I like to call mine localhost, which means I'm connecting to localhost on port 5005, and that's all specified. Actually, specified right here. Here's localhost. Here's 5005. Now, when you run a Java program, if you want that Java program to be able to receive a connection from a debugger, you need to add some extra stuff to the command line. So this is like, in addition to like java-jar, you would have this -agentlib thing. And what this says is the following. It's going to write JDWP, I don't know, some wire protocol or whatever. It's going to connect over a socket. Server, I don't remember what server means exactly. Suspend is important. Suspend says whether or not you want to wait for the debugger before executing the first line of code, which is suspend equals yes, which means don't execute code until the debugger attaches. Suspend equals no is like, yeah, go ahead and run the code, and then the debugger will attach later, which is what we want in the case of the servlet. And then it says that the address that I want to listen to is star, so like the local host, any address on port 5005. So I can select all here and copy it because I want to put this on the command line. Now I want to send this. I want to send this. I want to add that command line option to the Java command that is used to run Maven. Maybe something I haven't really emphasized, but Maven is written in Java. So when you run that Maven W script, that launches the Java VM, and it launches it with a special start Maven main class. Okay. So I want to add this to the command line, and the way I do that is I set an environment variable. So I'm going to export, and it's called Maven Ops. And by the way, all this information I believe is available in the Getting Started repository. Now that I think about it, just let me. I think I have a whole big section. Yes, I do. I have a whole big section here on how can I use a debugger to uncover the source problems with my projects. If you want to use the debugger, I recommend that you read over this. It's got some links off to how to do stuff in IntelliJ. Appreciate any feedback you have in terms of the quality of this documentation, because this stuff is important. So we set this Maven ops environment variable. And now when we run Jetty, it starts out with that listening for transport DT socket. That's an indication that is listening for a debugger to attach to it. So I've got my Jetty running there. Now in IntelliJ, I'm going to create this configuration. So now it's saying that the currently selected configuration is localhost 5005. And now I can click on the debug icon. And what this is going to do is it attempts to connect to whatever Java process is running on localhost 5005. By the way, this is different from the HTTP port, which is 8080, right? So, right. So when we communicate with our servlet, the HTTP protocol is being responded to on port 8080. The Java debugging protocol, which is a different socket on a different port, is connected to is being served on port 5005. So, but when I click the little green debug icon, IntelliJ will attempt to connect to localhost 5005, saying, "I'm a Java debugger. Are you a Java program we can debug?" And it's like, "Yes, I am." And so they get together and they start debugging, and so they're sending all this information back and forth. And what IntelliJ is telling you is like, hey, you have successfully connected to the target VM. Very good. Okay. Now I set a debugger here in do-get. And so now I'm going to perform a get operation. So I am going to go back here. I'm going to say list all dictionary entries. And remember what this does. This visits the phone call /calls URL. So I click this, and IntelliJ pops up. And it's this line 35 here, is highlighted in blue. And oh yeah, that's where my breakpoint was. Because when I sent the URL in the web browser to my Jetty routed that URL to the do-get method of my servlet. And now I'm running Java code. Now I'm working the debugger. And so it's telling me things like, it's executing this line, that's why it's highlighted in blue. IntelliJ gives me this little pop-up about the value, about the response object, because on this line I'm calling response.setContentType. So the content type is, and you've probably seen this, MIME types and stuff. It's basically saying, hey, what I'm about to return you, or what my response will contain, just plain old text, nothing interesting. And this is a hint to the client. It's like, well, this is the payload. This is how, so do you know how to render it? So like plain text/plain. Yes, the client knows how to render that. It could be, it could be a PDF file. It could be a JPEG. It could be, anything. And as long as the client knows how to deal with it, that's great. So anyway, so the debugger, so now we're stopping the debugger. Down here in IntelliJ, we get the whole call stack that it's on. And so here at the top is like a stack trace, right? We have do-get, line 35. Here's what's currently executing. And then everything who's called this is all sorts of, standard Java Servlet code and stuff from Jetty and who knows what. It doesn't matter, right? Because this is all the third-party code that's finally calling your code. You care about your code. Okay. In here, I can also inspect these objects. So here's information about my request object. It's of type org clicks Jetty server request. Well, that's great. That must be some Jetty object that implements the HTTP servlet request interface. And the debugger allows you to then get information about it. Now, this is like the guts. This is like the internal fields of things. And so I don't know exactly what all this stuff does. Let's just some things that are familiar. Like, oh yeah, here's the URI. Here is, okay, the context path and the servlet path. Well, that's neat. Oh, look, it's unauthenticated. Okay. What else do I got? Well, this is kind of interesting. It has a bunch of data, but this is like kind of the raw stuff. I don't know how useful that is. But one of the things that I can do is that I can, is that here? Yeah, I can evaluate an expression. And what this allows me to do in the debugger is invoke Java code. So I can say response dot, oh, I don't know, well, what do we got? We got get, oh, what would be interesting? How about get headers? This is probably all empty, but I don't know. Let's see what it's got for headers. It's got a date header. Okay, so this is send in from the client. That's kind of interesting. So it's a byte array. It probably means something. I don't know what that is. Oh, I'm sorry. No, that is the names of the header. So that's just date. And so now if I say get header, oops, which of date, let's see what that returns. Oh yeah. Okay, that was the date on which that's the response. Okay, that's the response.get header. I wonder what I get from the request. That might be a little bit more interesting right now. Get, oh yeah, that's way more interesting. So context path. Okay, phone bill. So if in your code you wanted to like find out, what the context path was, you can call this method. Get, oh, I don't know, cookies, not so interesting. Oh, they got header names there too. Oh, that's like an iterator. That's not super interesting. What else do we have for get header? Anyway, but this is the cool thing about, does it have a date? Nope, it does not. Get header, get headers, get header names. Okay, well, I guess this isn't. I don't know. Can I find out what these are? Oh, hash set. That might. Oh yeah, here's all of the header names. Like host. Okay, actually maybe user agent is a little bit more interesting. So get header, oops, of user-agent. Oh, yep. This is how Chrome identifies itself. So in HTTP, they have these things called headers, which is all this meta information about the request. And one of the things like, yep, the user agent is the identification of what kind of thing is calling me. Well, here it is. It's Chrome 103. Or actually, it's Mozilla 5.0, which is all of those different kinds of things. But anyway, this is what you can get in a debugger. And this your Java program is in the middle of running and is responding to your interactions in the debugger. Question, yeah. Uh-huh. Oh, yeah. How did I get to evaluate? It's this button right here, which is also Option F8 on a Mac. Okay. So anyway, you can introspect the program while it's running in the middle, right? And this is really great. Like if you're getting like a null pointer exception, it's like why is that null or what thing is null exactly? You can stop in the debugger and introspect things. We can also walk through the program. And that's what these buttons do here. So there is step over, which will go to the next line. There's step into, which will go into a method call. And then there's force step into, which even if there's a breakpoint. And then there's step out, which is just like go up on the stack. I'm done with this method, just return. Oh, and then there's like, render cursor. And there's also like a keep running, which is just to go on. But let's walk through this code and see what it does. Okay. So currently I set the content type. Yes. Oh, I didn't want to step into. I wanted to. So let's step out. There we go. Now I'm okay. I'm going to call a get parameter method, and I'm going to send it the string word with the request. So as you may recall, the URL has that question mark and then those key value pairs. Those are the parameters, and we'll see how that's used in a second. Okay, so now I'm going to step into the get parameter method because I want to see what get parameter does. So I say step into, and that brings me down to the source code for get parameter. So the first thing it does is it calls request.getParameter of name. Well, the name was passed in was the string word, which is the word in the dictionary app. And so I'm going to say, okay, what is the value of request.getParameter? So I'm going to step over that. I don't need to go into the API for get parameter because that's like servlet stuff. The value that was returned is null, which is correct because I didn't put any parameters on this URL. Oh, by the way, the reason I know it's null is because, well, it's telling me right here. But I can also hover over the variable, and it'll tell me it's null. This is all very nice stuff. Okay, so because the value is null, get parameter is the method's going to return null, and that's fine. So, okay, back here in my do get, well, okay, so no word was requested. And so what am I going to do? I'm going to write all of the entries in the dictionary to the response. Okay, well, let's see how I do that. I'm going to step into that. Oh, look at this. I'm seeing some APIs that look familiar to me. Okay. Now, the response represents, well, the response you send back to the client. And what you send to the client in HTTP? A bunch of text. How do you write a bunch of text in Java? You use a print writer, right? We've been seeing these things before. And so then the response object, which is one of these standard servlet response objects, it has a getWriter method that returns a print writer that when you write to it, that will ultimately get sent back to the requester, back to the client. So just the same way that you got a print writer and maybe wrapped a file writer around it to print to a file. Here, this is a print writer that writes off to the servlet response. And the cool thing about this is that it reuses an API that you're already familiar with. It didn't have a need to invent a new API. Instead, it's using a standard Java I/O print writer, which is great because it's familiar, right? So it makes the code easier to use. Okay, now I'm going to be doing project-y stuff. So I'm going to get that print writer, and then I have a text dumper that dumps a dictionary that looks just like your text dumper. So I'm just going to navigate into the class. Right, this looks really familiar, right? You have a text dumper that takes a writer, and then you just write some stuff out to it. And so then I'm going to create one of those. I'm going to use the keyboard shortcuts, and then I'm going to dump the contents of my dictionary. Now, dictionary here is a field in this class which contains the key value pairs, the names, the words, and the definitions in the dictionary. And so I'm going to dump that, which basically writes out those key value pairs. I'll jump into this. Oops. Oh, weird. Huh. Oh, is this the wrong text number? Oh, yeah, it's the one from Phone Bill, not the one from Phone Bill Web. Well, isn't that interesting? Okay. Huh. I don't think I've ever seen it make that mistake before. And so then I dumped it there, and we'll see the response later. And the last thing I do is I'm going to tell the response, hey, you're okay. So part of the response is not only the payload, but it's also the status code, right? And so this is where we say, hey, yep, good job. I successfully served the request, and so that my request is okay. And so then we're going to be done with this method. We're done with the calling method. And then the thing about that I called this was some crazy internal code. So I'm done debugging. And so I'm not going to run to cursor. I'm going to say resume program, which basically says, okay, yep, I'm done debugging for now. Be free. And now it's done. And so then it executes all the other stuff on the call stack and ultimately returns the payload here, which was empty because there's nothing in the dictionary. Questions? Yeah. Okay. Yeah. It's text. Do you care? Yeah. I mean, actually, is there a? No, I'm curious. Is there? Yeah. Oh yeah, output stream. Yeah. So you can also yes. So let's say you're serving up an image. And image is in bytes. Now, HTTP is a text-based protocol, which means that all binary information is being coded somehow. And the Servlet API takes care of that encoding for you, right? And so you can get the output stream, and then you could write a bunch of bytes. I mean, for instance, we could have it, write a GIF or something, here, and you just read it from probably a resource, and then write it to the output stream. That's Java. It's too easy. I don't know, which I'm sure you'd all agree with. Yeah. Nope. No, that's because here again, this is the hallmark of a good API. It makes things easy, right? Yeah. Sweet. Okay, well, so that's the do get. Let's look at the do put next. And so now, let's just go for the command line because it'll be easier. I'm going to do me, a name I call myself. Okay, I ran the Java program. It made a call via HTTP to the servlet, and now it's in the post. So when you create a new entry in the dictionary, it's a post. When you ask a dictionary for something, it's a get. Okay, once again, what am I doing? I'm going to tell my, the first thing I need to do is I need to tell my response, here's what I'm going to send you. Plain text. And so then, okay, it knows to expect that. And now I'm going to call the get parameter again with the word. Okay. And so then the word that I sent in was me, because when I invoked it, the first parameter, or sorry, the third parameter was me, and then the definition was a name I call myself. So then the word is me, and so it is not null. Well, that's good. Now I'm going to get the definition of the word, and the definition is a name I call myself. Great. So all the data is good. So I'm doing some data input validation, right? I'm making sure that it's not null, and we'll see an example. I think I can create an example where it's null here pretty shortly. I've got my word. I've got my definition. I'm going to store it in the map. So I'm going to say this.dictionary.put. This is no magic, right? This is just like Java Collections API, right? Call the put method. Okay, good. I'm storing it locally. And now I'm going to write in the response. I'm going to get the writer for the response, and I'm going to step into the defined words as method here, which is just a little text formatting thing that I use. I think having this defined externally makes it a little easier to test. So so I format the little message that I want to send back to the client. Step over that. That has now been written to the print writer. I flush it just to make sure that all of the data gets written, and I'm like, okay, the world is good. And now, once again, I am done with my. Oh, sorry, I need to. Oh, yeah, I'm done with that. I will continue on. And now my Java program is done. By the way, you might not have noticed, but as I was debugging that, the program hadn't returned yet. Actually, let me just do that one more time. Dear email, dear. So notice that I haven't gotten the prompt again. The Java program is still running because it's made this request off to the server. I'm sitting here debugging, and now that I'm done, so it hasn't returned yet. I'll say, yep, I'm done debugging. It just continue running. It continues running. The request returns, and now the program returns. So this is the thing, right? You've got moving parts now. Didn't used to have moving parts. Now you've got two programs talking to each other. That's what makes this one complex. And also makes it kind of fun. Okay, so we've got that. And then, let's see if we can get ourselves an error situation, which may be, let's see here. I bet if I say Ray and then I don't have anything here, let's see what happens here. Now I'm trying to create a dictionary with, actually I can put nothing in here and let's see what happens. So I just do this. Okay, here I am in my post method again, right? So I'm posting empty content. So I'm going to set the content type. I'm going to get the word. The word is null. And so now I'm going to say, now something bad's happened, right? You said to create a definition, but you didn't give me a word to define. So I'm going to dive into this missing required parameter. What does this do? Okay, it gets an error message. And so then, okay, it just says the required parameter, whatever, is missing. It's good to know. And now, this is a bad thing. And so then the response isn't okay anymore. It's frowny face, right? And so now what I'm going to do is I'm going to tell the HTTP servlet response, send back an error. And the error code is 412. Right? HTTP error codes, that are in the 200 series are good. That are in the 400 series are like, I couldn't handle the request, 500 internal errors, right? So using 404s, you're all that kind of stuff. Good. And the message that I want to send back with the error is the text I just formatted here. And so this now will send an error back to the caller. And so now it returns from the doPost method. So I'm just going to continue debugging here. And now when I go back to the browser, sure enough, it gets it gets the error message. The required parameter word is missing. And actually, we'll see that you can that also that 412 was returned. So that's what the servlet does. It responds to do get. It responds to do post. Oh, by the way, I'm going to stop. I'm going to detach the debugger by stopping the run configuration. And now when I run something, it doesn't stop anymore because okay, the debugger stopped. That's what the servlet does. It responds to the get and the post. And so what this project is all about is implementing some functionality based on that, and let's talk about that now. Actually, before we do that, any more questions about the servlet or what it does and how it does it? Now that you understand a little bit more about what happens on the inside, let's talk about what your project does. Okay. So you're going to take the phone bill servlet that comes out of the box. You're going to modify it to support access to phone bills. And so then the servlet should support several URLs. So it's phone bill calls, and if you say customer equals name, that will return all the calls in the phone bill. Sorry, and you send it and you do a get on that. It'll return all the calls in a phone bill for the customer with the given name using your text dumper. So now so in your projects 2 and 3, use your text dumper to dump to a file. Well, now you're going to use your text dumper to dump to an HTTP servlet response. If you post to the calls URL with the customer for the given name, it'll create a new call, and you have to pass on additional parameters beyond customer. You need to provide a caller number, callee number, begin and end. By the way, this is case sensitive. They have to be called this one. And this is how you create a phone call on the server is that you post to that URL and then you send it the payload. And by the way, if the phone bill does not exist, you should create a new phone bill. So the servlet needs to support that URL for managing, for getting and creating phone calls in a phone bill. And then there is a new piece of functionality, which is searching searching a phone bill for calls that meet certain criteria. So here, when you have customer, a begin and an end time, so no caller numbers or callee numbers, when you do a get request of this URL, it'll return all of the phone bill's calls, all the calls in the phone bill, formatted using the text dumper, that begin between the begin time and the end time. So this is it starts between the begin and the end that's passed there. And note that the format of the date and time in the URL is the same as in the command line. Yeah, question on that? Is that inclusive? Sure. I don't test the boundaries. Yeah, that'll be fine. Yep. So you support these two URLs in the servlet. And note that you can support multiple phone bills. So in your previous projects, well, I guess you could have one phone bill per file. You can support multiple phone bills all in the same thing. You don't write to a file in this project. Just to be clear, you don't need to. There is no location for files, which means that when we end the servlet process, when we end the web server process, then all your data goes away. That's fine. That's the way this program works. You don't need to make it any more complicated than that. You'll see the text. You'll see the file persistence again in Project 5 with Android. So on the server side, you have a servlet that supports all this stuff. Let's see here. Should it throw an error if there's a duplicate customer name during a post? Nope. It should just add a new phone call to the phone bill. Yep. Good question. There's also a client program. So we have the project 4, and that's what we use the Java-jar. Oops, that is not correct. It should be phone bill client. I will fix that. I'll make a note there. Phone bill -client, which looks kind of like your your other programs. So it's got the customer, the caller number, it's got begin and end, just like project 3. But it's got some options. So it's got dash host, which is the host computer in which the server runs, dash port, dash search, which will execute the search, and then our old friends dash print and dash readme. Because the command line is a little different, here are some examples. So here's how you add a phone call to the server, right? You run your java-jar and you give it, let's say that it's running on localhost port 12345, okay? And then you give it the same commands that you did in project 3, same command line argument. So again, the dates are the same format. You can search for calls that begin between 2 times with this. So notice that it's with dash search, you don't need, as a matter of fact, you shouldn't have the 2 phone numbers. It's just the name of the customer, and then the time range for when phone calls begin. And then if you want to print all of the phone calls in a phone bill, you just have the name of the customer. Yeah. Yeah, the customer name doesn't really, again, there's no files. So it's the name of the customer of the phone bill, right? Which means that you need to have the ability to find the phone bill for a customer. The servlet holds all of the data, and so then when you get a request for a particular customer, you go find that customer's data. I don't know, what do you mean by splitting and separating exactly? Okay, well, think about it, and it might become a little more clear as we work on it. Okay. Yeah. Oh, okay, right. Remember in the search, you give the customer name. Right. So every operation requires a customer name. Very good. Yeah. No. Excellent question. So like even like in the URL, like when there's always a customer name. Yep. No. Right. So like when you search, it is you search within a customer's calls, not across multiple calls. Excellent question. Yep. Okay. Thank you for explaining that. Yep. Yeah. Okay. So and as always, make sure that you give good user-friendly error messages when things don't work. And that's the project. Let's see here. We've already gone through all of this stuff. I reiterate it here. There's some examples that you can look at. We'll focus in on the request helper and stuff like that next week. You can run Jetty on a different port by putting this -d. And note that only you won't be submitting the pom.xml or the web.xml. I'll regenerate all this. You'll just do the source code. Yeah. So basically, the Java files, any .txt files, any just that kind of stuff, the same as before. So that's what your program needs to do. And as you can see, there's a lot more there. Now, what I found is that what you get out of the box gives you a good place to start. But there's a lot of moving parts. It's really different. So I encourage you to start playing with it, as soon as possible, acknowledging that you're, still also have your project 3 to be working on. Oh yeah, and your cones to be working on too. So nice. Any questions about the assignment itself? Yep. Yeah, and the server's not running here. Again, you should have like a reasonable connection to the server cannot be established. So do something reasonable. Yeah, there's like an null pointer exception. Yeah. Okay, yeah. Right, you said, oh, go ahead and copy your source code from previous projects. So I also need to bring over my tests. If you want the coverage, yeah. Right. So yeah, you have to bring over the tests also. But hopefully, if but you'll want to do that anyway, because if you have to make some change to like your text dumper or something, then or your pretty printer, then you'll want to make sure you have tests for it. So yep, need that. Question on chat: Does it submit with a script like other projects? It does. So yep, the submission process is the same. Okay, let's take another break. Let's do 12 minutes. Come back at 7:35. I want to talk about the unit tests. We'll do that, and then then it'll be time for the Kata for the pair programming. Sweet. Hey everybody, let's see here. We had a couple of questions that came in at the end, so let's really quick do a recap, and then we'll get to those. So we've been talking about Project 4 tonight, and we've talked about how it is demonstrably different than the other projects that you've worked with. We now have two Java programs that are talking to each other. We saw the structure of the application or of the program, the fact that it comes again in these two parts that talk to each other. And then we looked at the code a little bit. We used the Java debugger to attach to the web container and step through the do get and do post. And so we saw that those methods were invoked in response to an HTTP request coming in either from the browser or from the client. Very different than what you were working with before. And so then please take that into account as you approach this project. So a couple more questions came in. What's the difference between a web app and a JNLP? Glad you asked. So the JNLP is Java Network Launch Protocol, which was a way of launching a native Java application that was downloaded from a website. I think it's largely fallen out of favor. I don't know if people still do these things, but maybe you encountered it at work or you saw something about it. It's a neat little thing. I mean, you basically deploy and by application I mean like a thick client application written in Java. So a web app is just a web app. So a web app is usually if there's any user interface associated with it, it's HTML and JavaScript, right? So it's a web app, and that can be posted, and that can be served from Java. JNLP is more about downloading Java code and then running it locally in your environment. And the question about the assignment. So the post should be done with URL parameters and no body. No, it's the body. And we'll see probably next time how all of that is done. I mean, we'll see a little bit of it when we talk about the unit tests. And then a question about if I did the pair programming last week, do I need to do it this week? No, you don't. I know it's kind of a long haul tonight, and maybe you're still working on your project or want to get a head start. I think the pair programming, the Kata is fun tonight, but hey, it's if the requirement is that you need to attend one pair programming. If you've already done that, then you've met the requirement, and so feel free to use your time appropriately. Okay. So now we walked through. I want to take a look at the servlet. We walked through the servlet. We saw the do get. We saw that the do get and the do post. This has logic here, right? I mean, this is like taking in the inputs and doing with things, and returning the outputs. And the project, when you implement it for real, when you do things like query the phone bill, or when you create a new phone call, you'll be doing stuff. And when you do stuff, you want to test it. And actually, in this class, when you do stuff, you have to test it. But how do you test this code? Right? This code requires, in order to invoke do get, you need to pass in an HTTP servlet request. You need to pass in an HTTP servlet response. Now, these are just interfaces. I think these are interfaces. Yeah, these are just interfaces. But they've got like a ton of methods. And so, I mean, it's possible, I suppose, to implement your own subclass that you could test with it. but there's a better way. So so this project has a unit test for the servlet. And the servlet, the unit test, calls the doGet method. It goes and calls it. In order to invoke it, though, you need to send it an HTTP servlet request and an HTTP servlet response. So let's take a look at what it does. So the doGet method, sorry, one more time. The doGet method it takes an object that implements this interface. Now, at runtime, when you run Jetty, and we saw it in the debugger, right? It has some internal implementation from Jetty or from the Servlet API of this request interface. Great, but this code, it just programs to the interface. It just knows that it needs some object to do that. So what the unit test does is it creates what's called a mock object. Now, mocking is a commonly used technique in unit testing, where you have an object, or you need an object that is expensive, like a database connection or a connection to a REST API, or something kind of crazy like an HTTP server request. It's kind of a complex object. It's got a bunch of methods, but you know what? Shoot, we only need a couple of methods. We call set content type on the response. Here in get parameter, we call get parameter. So of the dozen plus methods on these interfaces, we only need a couple. There is a library called Mockito that allows you to create mock objects, which are objects that implement the interface, but then only implement parts of the interface, only implement certain methods of the interface. And what you can do is you can create one of these mock objects, and then you can send it to your code under test, like doGet, and then you can program, if you will, the mock object to behave in certain ways, and only the ways that you need it to behave, and then verify that your code interacted with the mock object like you expected. Now, this is another really kind of advanced concept, but it goes really nicely with these servlets because it allows you to test the servlets. So there's kind of some wacky syntax, and this is one of those times where it's a little bit of magic. But please, I encourage you to review the dependency injection lecture because this is where we talk about all this stuff. This is really cool and will help you write some really great unit tests. So we're going to test that initially when you create a servlet, it contains no dictionary entries. And more strictly speaking, we're going to say, hey, listen, when I ask for all of the dictionary entries in a newly created servlet, it returns 0. So, or actually, it doesn't return 0. It never, it sends no output back, right? We saw that. We saw that here. Well, let's see here. I think this, here, we're going to restart. Jetty, which will be basically create a brand new servlet. It doesn't have any data in it yet. And when we ask for the calls here, we're just going to refresh the page here. It returns nothing. So basically, what we want is a unit test that verifies that when you create a brand new servlet and ask for the phone calls and the phone bills, or rather, this dictionary. When you ask for all the dictionary entries, nothing is written. So what does that mean? Well, it means that when the doGet method is called with a request that represents this right here, which is a request with no parameters to it, then nothing should be written to the print writer associated with the response. And we've encoded that here in this test. So what we do is we create our servlet. This is our servlet under test. So we're instantiating our servlet object just by calling its constructor. It's actually what Jetty does under the covers, but we'll do it here in our unit test. So we create our phone bill servlet, and ultimately we want to call our doGet. We need to send it a request and a response, and both of these are what are called mock objects. So Mockito has this method called mock that you can call, and you give it the class that you want to mock. If you don't know what the syntax is, go go watch the reflection lecture. So create me a mock one of these, okay. And that returns an object that implements that interface. And same thing with a response. We have these two mock objects, a mock request and a mock response. Now we also because we know our doGet method is going to interact with that request and that response. You have to pass it something. You just can't pass it null. You have to pass it a real object, and then the doGet method is going to interact with that object. Now, what's very important is that when in the doGet method, when let's see here, we are going to call eventually write all dictionary entries. It calls get writer from the response. So this code right here expects that the response is passed in has a writer associated with it. Oh, a couple questions have come in. Is it single threaded? The unit test is single threaded, yes. Mock blocks, I'm guessing. I don't know what you mean by mock blocks. Oh, okay, I'm sorry. Do you mean that the calling waits the request to finish? Okay, good question. We are not actually, so this is a unit test. Tomcat doesn't run. You are thinking of a test that would actually, not Tomcat, Jetty. You are thinking of a test that will actually call the REST API. Am I correct on that one, Jacob? Yes. This test doesn't do that. This test runs, here, I'll kill the server. This test runs and doesn't actually interact with the server at all. It just interacts with the code. That's what's so wacky about this. This calls doGet directly. It doesn't make an actual HTTP request. Instead, it mocks out the HTTP request and the HTTP response. We will see next week that the integration tests, yeah, they actually call the REST API. But this week, we're just looking at these unit tests. So what we do is we create our mock request, our mock response. We need the getWriter method to return an object, so we'll create a mock print writer too. Why not? Okay, and so we create a mock print writer, and then we tell the mock response, hey, listen, when your getWriter method is invoked, then return our mock print writer. This is crazy. You're like creating these mock objects. You're kind of like programming them to do like little things using this when API that has a then return. But it works, and it's super cool. And now you can send the mock request and the mock response to doGet, and when it then interacts with things like the response object, it calls getWriter. It returns the mock print writer. Does this code care that it's a mock print writer? No. All it cares about is that there's an object that implements the print writer interface, and it will call via this dump method. It will call print line on the writer. Okay. Well, that's neat. Question, yeah. Yeah, let me go back to the test here. Yeah. No, it's basically saying that the implementation of getWriter is to return this mock print writer. Yeah, I mean, this is like this is a voodoo, I got to admit. Like, when I first saw this, I'm like, wow, Java Reflection is so cool. I can't believe they did this. I mean, like, this is one of the very few times in my career where I've generally been like impressed and surprised at something. It's like, oh wow, someone was able to do that. That is so cool. Anyway, so you can send these objects to doGet, and your code, this is the code that you wrote, the code that is under test. It doesn't know. It's fine. It's just interacting with these objects just fine, and all of that ends up working because you have basically told these objects what to do in all the situations that they're interacted with. And so once you do that, you can then interrogate or query the mock objects to ask them how they were interacted with, and then you assert that they were interacted with the way that you expected. So for instance, you can say, hey, verify that my print writer object never had its print line method called with any string. So you're basically saying, it's like, hey, I'm going to assert. verify is a lot like an assert. It's basically saying, hey, I assumed that when doGet was called with a request that had no parameters associated with it, that nothing was ever called as print line. I also assume, I also want to test here, that set status on the response was invoked with servlet. Oh, sorry, with the response of OK. Right, that's what this code does. All right, so if we go back and look at it, oops, I'll do it this way. we'll say that, actually, maybe if I do the split screen, it might be a little better. Right. So we'll start with the doGet method. doGet method, yeah, it calls set content type, but who cares? Get parameter is called when the request.get parameter with any name is called. By default, the mock object will return null. Right? It doesn't know what to do, but like you call it get parameter. I don't know. I'm a mock object. What do I know? I wasn't told to do anything else. I'm going to return null, which is actually what we want in this case. We'll see a case where it returns something else shortly. And so it returns null, and so our code says, okay, well, get parameter is null. So then that goes back up to where it was called, get parameter is null, and so then you go down here to write all dictionary entries. You send in the response. This test sends in the mock response. The code doesn't care. It calls the print writer, sends the print writer to the text dumper. It dumps it. Because there are no entries in the dictionary, then it, that's so interesting. Why does it, oops. Yeah, so this one, yeah. Oh, there it is. Now this is the right one. It dumps this method here. The dump method will go through all of the entries in the dictionary. There are no entries in the dictionary because it's a brand new created thing. So print line is never invoked. Actually, I suppose we could assert that flush is invoked, but we don't care. And then let's go back up the stack here. Oops. And then we call response.setStatus with SCOK, and that's what we assert over here. So this is white box testing. You are testing that the code behaves, that it interacts as you expect. But what it allows you to do is to test the servlet without running the servlet container, which is big because this test runs in a matter of milliseconds. If you actually had to start up Tomcat and then query make the HTTP request, that whole turnaround time takes seconds, if not closer to a minute. Yeah. It's a JUnit test that uses the Mockito API to create mock objects to send your code under test. Oh, good question. So could you put the mock creation? You can create the mocks in a before each, but you really want to configure them on a per test basis. So I don't know if that will really buy you much of anything. And I think I like having my preference is to have sort of like locality of data, and so I sort of create everything here so I can look at all at once, as opposed to like, oh, this field's up here, right? Yeah, so anyway. This was kind of mind blowing. I got it, right? We got some more examples. Any questions before we move on? Okay. Here is a unit test that adds one word to the dictionary and verifies that the word was actually added to the dictionary. So here we are going to be doing a do post because do post is what creates the words. Now our mocks are getting a little bit more complex. So we have a word, a test word, and a definition. So this is like our test data, and actually here's our object under test, our servlet. Now we're going to create our mock request and our mock response. Oops. Mock response. Here we're going to train our mock request to say, hey, listen, when your get parameter is invoked with word, and actually I could have used this constant up here. Actually, that's probably a better example. So that is this is the these are the names of the URL parameters that are in these constants. I should totally change that. I'm going to add a note there. Plus use fields in Mockito test. Use servlet fields. Mockito test. I'm never going to be able to read that. Okay. So when the word parameter is requested, then return our value word. Similarly for definition, return definition. So this basically mocks out the URL that is is sent when you, okay, this is all going to blow up. It was sent when you, it doesn't the URL. It mocks out the HTTP request that occurs when you have the key value pairs here in the create dictionary entry. And we're going to create our mock response again. Now, for the print writer, not only do we want to, so in this case, we do expect some output to be written to the print writer. And what we want to do in our test is we want to capture that text that's written to the print writer and then verify that it's what we expect. So we expect that it is this defined words as. So let's go back and look at our code again. Let's go look at do post. So do post, we check to make sure that the word parameter returns something that's not null, that the definition parameter returns something, something that is not null. We put into the dictionary, and then we get the print writer from the response, and we write this defined as words string, which is, okay, define some word as another word. Super sweet. We want our test to assert that, yes, whatever was written to that print writer is the result of the defined as words. And this is why I have this defined as words. It makes it just easier to have like this code that formats that string defined in one place, and then I call it over here and I call it in the test. So what we do here is in the previous one, we used a mock print writer because we just wanted to make sure that it was never interacted with. Well, here we're going to use a real print writer that that writes to a string writer, and that will allow us to capture the text that was written over here by this print line over here in the real code, and then make sure it's what we expected. So what we do here is that when we say, well, when response.getWriter is called, return this print writer, which isn't a mock print writer, it's a real print writer wrapped around a string writer. A string writer is just implementation of writer that writes to a string of memory. Okay, so then we're going to execute our code. We're going to say do post with our mock request and our mock response. That returns a real print writer. And then we expect that when all that happens, the print writer will be requested, and its print line will be invoked, which will actually write to the string writer. So then we'll get the value of the string that was written to that string writer that underlied our print writer, and we want to assert that it contains this string that ought to have been written to it over here. Additionally, so we want to capture the text that was written to the print writer, and we also want to make sure that the status code that was set was set to SCOK. Now we could use the same code right here, verify response, set status to that. But there's another aspect of the Mockito API that I wanted to show off, and that's something called argument captors. So what we can do here is we can capture the value that was sent to a mock objects method. So in this case, we want to say the following. We want to create something called an argument captor for something that's an integer, right? The thing that is passed to set status, this is an integer right here. It's an int. And so then this is an int constant. It's 200. We want to capture that integer and then interrogate it. So then this is a Mockito thing, and watch the Mockito lecture within the dependency injection to learn more about it. But you say, hey, give me one of these argument captors, and then I want to say, hey, verify that my response had its set method called and with a certain value, and please populate that value into this argument captor. And now, and capture that value, I guess, in this argument captor. Then I can assert that the value that was captured is indeed the one that I expect, which is SCOK. And then you can use this for like getting other kinds of basically, yeah, capturing the data that was interacted with your mock objects. So this is verifying that the request and response were interacted with in the way that we expected. Finally, we have like a normal assertion that basically says, hey, listen, I've gone through and I've done the post and I verified that, yep, the right stuff was written back to the response and that the error code was right. I want to make sure, though, that the data was actually stored. And the way I do that is I call the get definition method here in my phone bill servlet, which is, by the way, only visible for testing. And what it does is it basically says, hey, give me a definition for the word word, and it looks up in the dictionary. So this is just yet another type of validation that your test can do. It sort of reaches into the servlet and says, hey, give me the definition for the word. It doesn't go through the do get method. Instead, it just calls it, which is fine to do in a test. So this is how you can test your servlet. And I know it's really complex, but it's actually very powerful. And it lets you write unit tests, which again run so much faster than the integration test that we'll see next week for your servlet. Any questions about that right here and now? I know it's a lot to take in. Okay. Well, anyway, that's everything I wanted to talk about Project 4 tonight. This is due in 2 weeks, 3 weeks. Oh, it's got to be 3 weeks. I hope. No way, July 27th. That's 2 weeks. Is that right? Son of a gun. Did I do that right? Project 4. Assign Project 5. And that gives you 2 weeks for Project 5. Yeah. We'll revisit that. We'll see how people do. Next week, if people are still lost, well, boy, that's really tough though, because then it's like Project 4 is due the second week, last week of class. Project 5, yeah, 8-week class, 5 projects, yeah. So okay, this one will be fun. Yeah, we'll see some more of it next week. But encourage you all to get ready. Is that really right? We have. Oh yeah, no. Wait, you have. Yeah, 1, 2, 3. You have 3 weeks. Wait, 1, 2. No, 1, 2. Okay, so the next week we'll see more of it, and then we'll. Oh right, we'll. Okay, yeah. So next week, yeah, there's no. Oh yeah, there'll be some Android stuff. Yeah, we might. Yeah, I guess we'll start learning about Android next week, and then we'll really dive into it in week 6. Okay, cool. Whew. Lots of good stuff. Ask questions on Slack. There is a Project 4 channel already. Okay then. Question? Yes. There's Android Studio, which is so. What tool do I use to develop Android applications? I recommend Android Studio, which is a derivative of IntelliJ. It's IntelliJ with a whole bunch of Android features added, basically. Yeah. Nice. Yeah, we'll start seeing that next week or the week after next. Okay. Excellent. That's all the Project 4 stuff. So what's left for tonight is the pair programming on the katas. So I will. Let's kick off the kata. Let's talk about that, and then we'll break up into pairs. And again, yes, I hear people leaving, and that's fine. If you did the pair programming last week, no need to continue on. Okay, so last week's kata was really simple. This was a little bit more interesting. So you are modeling the Mars rover, and I will post this here in the chat for anybody who's interested. Playing along at home. So basically, you've got you are NASA Mission Control, and you've got a whole bunch of robotic rovers that land on Mars, and you want to explore the Martian surface. And in fact, there's a particular plateau that you were looking at. And it just happens to be rectangular because it's easy to model. And so you want to have the rovers move all over plateau so they can gather some data and send it back to Earth. And so what you do for this kata is that you are modeling this plateau, this rectangle, which has dimensions x and y, and it's a grid. And the origin of the grid, so coordinate 0, 0. Let's see here. I believe 0, 0 is in the bottom left corner, and then the plateau has a height and a width. And each rover has a position and has a direction. And so then there's the position is a coordinate like 0, 0, and then a direction north, which means that it's pointing north. And you can send control commands to the rovers as a string of letters, right? So you need to move around. And of course, you're sending these things, from Earth to Mars, and so you got to send the whole packet, and it gets there. So you send these commands, which is a string of letters, and there are 3 letters. There's L, R, and M. Left means turn right 90 degrees. Right means R means turn right 90 degrees. Sorry, left and right. And then M is move, which means move 1 step forward in whatever direction that it's heading. So, for instance, if you are facing north and you go, if you move, then you go from your current coordinate to 1 more on the y-axis. So there is an input to the program. The program starts out with the let's see here. See the upper right coordinates. Oh, upper right. Yeah. On the the first line is basically the size of the grid. It's the upper right coordinates. So it starts at the lower left and goes to the upper right. And then the rest of it is the initial position of each rover, and then a series of commands that you send to it, followed by the initial position of the next rover, and then commands that you send to that. And then the output of this should be the final position of each rover and the final direction that each rover faces. So a fun little thing is kernel logic, I guess. If anybody did Logo when they were a kid, and I think this makes a really good pair programming Kata, as it it lends itself pretty well to test-driven development, and also some more interesting object modeling than we did last time. So, any questions on the Kata before we break into pairs? I am going to, let's see here, we only got 9 people left, so that's fine. I will create 4 breakout rooms. For that, I'll let people choose which room that they want to do. I will create the breakout rooms, and if there's anything else, let's go do it. We'll check in at, like, I don't know, 8:45 and be out of here by 9:15. Okay.